Hello everyone and welcome back to the Pythagorean Room. In this video I want to talk to you about parallel lines and angles. First we'll cover some important definitions, and after we'll go ahead and work on some practice SAT problems. The first definition I want to cover is that of parallel lines. We say two lines are parallel if they do not intersect. Note that the distance between these two lines is going to be the same all the way throughout the lines. Next definition is a transversal. A transversal is a line that intersects two or more coplanar lines at different points. In this case, the transversal is indicated by a red line. Now we'll take a look at different angles. We'll define vertical angles. Vertical angles are those that their sides form two pairs of opposite rays. We have a theorem that says that vertical angles are congruent, and thus angle x and y are going to be congruent. This happens regardless of the measurement of x and y. Next, we'll take a look at complementary and supplementary angles. Complementary angles are those which their sum adds up to 90 degrees. We say that each angle is a complement of the other. On the other hand, supplementary angles are those which have a sum of measure 180 degrees. In this case, we'll say that each angle is a supplement of the other. Finally, I want to cover three very important definitions. We'll start by drawing up two parallel lines and a transversal that crosses them. First, we'll look at corresponding angles, which are angles that have a corresponding position. Here are two angles that are corresponding. Note that if we lower down the top parallel line, the one angle falls on top of the other. Thus, we can say that these two angles are congruent. Next, we'll look at alternate interior angles, which are angles that lie between the two parallel lines and on opposite sides of the transversal. Once again, these two will be congruent, and we can show it by lowering down the top parallel line and showing that one of the corresponding angles is actually vertical to the original interior angle, and thus they are congruent. Finally, we'll look at alternate exterior angle, which, as the name suggests, they're angles that lie outside of the two parallel lines and on opposite sides of the transversal. As you may have guessed, these two are congruent, and we can show it once again by lowering the line and demonstrating that these two vertical angles are congruent. Finally, we'll take a look at some problems. In this problem, we are given a triangle and a couple of parallel lines, namely L and M, and two angle measurements, namely Y and Z. And we're asked to find the value of angle x. To do this, we'll first note that the sum of the interior angles of a triangle has to be 180 degrees. Thus, the sum of angle x, z, and a new angle that I will label p will have to be 180 degrees. Thus, we'll start an equation saying that p plus z plus x is equal to 180 degrees. Next, we'll look that angle y and angle p are corresponding angles since L and M are parallel. Thus, angle y is equal to angle p, and we can substitute their value into the original equation. We can write then 20 plus 60 plus x is equal to 180 degrees, making x equal to 100 degrees. In this final problem, we're given that the segment RT and TU are both congruent, making the triangle RTU an isosceles triangle, and thus angle R and angle U are congruent. I'll start off by labeling a few angles that we'll see that are important for our solution, namely angle P, angle Q, and angle Y. Now, we can write an equation for the sum of interior angles for angle R, T, and U, such that R plus T plus U is equal to 180 degrees, and thus R and U, since the triangle is isosceles, will be equal to 33 degrees. Next, we'll note that angle P is the supplement of angle T, such that P plus T is equal to 180 degrees, making P 66 degrees. We can use these two values and the given value for S to find angle Q. We'll set up another equation for the sum of interior angles such that 31 plus 66 plus Q is equal to 180 degrees, making Q 83 degrees. Now we'll note that angle Y and Q are both vertical angles such that they are congruent. And using the already known value for R, I can set up a final equation such that R plus Y plus X are equal to 180 degrees. And substituting the values, we'll get 33 plus 83 plus X equal to 180, making X equal to 64 degrees. I hope you find this useful, and I'll see you next time.